नमस्कार दोस्तों, वेलकम टू गेट वाला. दिस इज डी सतीश कुमार, faculty of electrical and electronic measurements. How are you all? I welcome you on this platform of gate wala in English. Completely we are going to discuss complete lessons in English. Okay, so from today onwards, almost for the next 5 days, I am going to discuss electrical measurements, important topics on YouTube channel. How many of you are from electrical background, or how many of you are from EC background? You can type over there, and some of the instrumentation students also may be watching, so for them also you can type over there. Okay, so today's topic is error analysis, but before that let me talk about the syllabus of the measurements and gate EEE. So please confirm me how many of you are watching on the YouTube English. So please confirm me whether you are from different backgrounds. Once you please confirm me. Yes, engineer. Okay, so if you see the syllabus of measurements for the gate, electrical and electronics engineering, and of course for instrumentation students it is somewhat lengthy and descriptive. So if you see the topics here, the topics are bridges. So these are the topics like bridges, potentiometers, measurement of voltage, current, power, energy and power factor, instrument transformers, digital voltmeters and multimeters, phase, time and frequency measurement, oscilloscopes, error analysis. So maximum these are the topics of the syllabus. So the very first topic I have chosen here is error analysis. What I have chosen is error analysis. So all of you get ready for this particular topic, error analysis. Once, better to note down the syllabus blueprint. I always say to the students to have the syllabus with you. Syllabus blueprint is more important when you're solving, when you're going for a gate oriented subjects. Yeah. So the very first topic I have chosen error analysis, because remaining all topics we are going to discuss after the measuring instruments. But my intention here is error analysis has to be discussed first, because the basic error analysis is a common topic for error is expected either in the measurement of current and measurement of power, measurement of voltage. Anywhere you can expect this particular topic. So that's the reason I have taken this. Yeah. So if you see the error analysis, in error analysis, if you see, what are the different types of things that we have to understand first? The very first topic that you have to understand is the static characteristics of instruments. Static characteristics of instruments. So what are the static characteristics of instruments? Fundamentally, for every instrument, these are the static characteristics: accuracy, precision, threshold, resolution, range and span, sensitivity, repeatability, reproducibility, drift, dead zone and dead time, and static error. Please make a note of all these particular topics first. So having a list of all these topics as a beginning itself will be very useful for the students, because these particular topics are very, very essential in the list of instrumentation and in the list of electrical. So first of all, if you see the static characteristics of these instruments, what is accuracy, what is precision, what is threshold, what is resolution? Just let us have a brief introduction. So if you see the accuracy, first, what is accuracy? What is accuracy? Accuracy is defined as the closeness to the true value. Is defined as closeness to the true value. Is defined as closeness to the true value. It is defined as the closeness to the true value. How far it is close to the true value, that is called the accuracy. Okay, so generally accuracy is related to some, like, error can be expressed generally. What is error? Measurement value minus true value. But error also expressible as a percentage of guaranteed accuracy error. So here itself I want to explain percentage of GAE. What is this? This is what we call as guaranteed accuracy error. What we call this as guaranteed accuracy error. So what is this guaranteed accuracy error? It is the error guaranteed whatever may be the situation. Okay, so error guaranteed. Error guaranteed. At any cost, whatever may be the care you have taken, the error is guaranteed. Second thing is, it is always with respect to full scale value. Always it is with respect to full scale value. Always it is with respect to full scale value. And it is constant. It is given by the manufacturer. It is given by manufacturer. So how to understand this? For example, if you take a voltmeter, this is, let us take 0 to some 100 volts, 0 to 100 volts, and the percentage of guaranteed accuracy error is 2%. Okay, so what is that percentage of guaranteed accuracy error? Percentage of guaranteed accuracy is 2% over the full scale value. So if you see the full scale value, that is 2 by 100 of 100, so that will be 2 volts. That means the reading will be 100 plus or minus 2 volts. The error is from 98 volts to 102 volts. So this is the scenario of the error. You understand? So 98 volts to 102 volts. How many of you are there in the live? Please type your chart. I want to see your doubts also here. So the value that we are going to see here is 98 to 102. Please be interactive in the session. Yeah. So if you see here, this is the percentage of guaranteed accuracy error, which is going to be always guaranteed whenever that you are measuring over a value. Whenever you are measuring a full scale value, you are going to get this much. Okay. But the point here is, if the value of measurement is not this full scale value, the value of measurement is the less than the full scale value. Suppose if the value of measurement is less than this full scale value, what to do? The value of this measurement is less than this full scale value, what to do? For example, my measurement is suppose 50 volts. So now for a measurement of 50 volts, what will be the error? So I have purchased a voltmeter. I have purchased a voltmeter whose full scale value is 100 volts, which is having a error of 2% at the full scale. That means if I use this particular voltmeter and if I measure 100 volts. Good evening Mastrix, good evening, how are you? So if I measure by using this instrument a value of 100 volts, I am going to get a 2% error. Whatever may be the care you have taken, either it can be 98 or it can be 102. Measurement value is always different. Actually, it can not be this much, but practically this is the value. 98 volts, we are going to get a lesser value, 98 values. So if this is a scenario, by using this instrument, if I am measuring an intermediate value of 50 volts, then what can be the error? So that is what we call as limiting error. That means your error is going to be limited to a particular piece of measurement over the range. So for a limit of 50 volts, the error is dash. So how to calculate this? So this is what we call as limiting error. So how to understand this limiting error? So that will be what? So our error with respect to value of how much? 50. So the error is 2 divided by with respect to 50 to 100. So it is going to become how much? 4%. Going to become how much? 4%. So this is the percentage of limiting error. How many of you understood here? So 4% of what? If you check again, 4% of 50 volts, that is going to be how much? 4 by 100 into 50. So that is going to be again 2 volts. So this is what we call as limiting error. Limiting error remains constant. Okay, na? So but the percentage of limiting error is different. So I want to write here limiting error. So if the error is expressed, with reference to a value other than lesser than full scale value, then it is called limiting error. If an error is expressed with reference to a limited value other than full scale value. Good evening. Okay, so limiting error is always constant. Limiting error is always constant, but the percentage of limiting error is variable. Percentage of limiting error always not constant. Percentage of not constant. I hope you understood. Okay, chalo. So now let us go for this question. It was GATE 1993 question. So try to answer this question. How many of you are there in the live? Try to answer this question. Try to answer this question. Anybody can answer this question? The percentage limiting error, I think this question is clearly visible. The percentage limiting error in the case of an instrument reading of 8.3 volts with a 0 to 150 volts voltmeter having a guaranteed accuracy of 1% of full scale reading is dash. So the percentage limiting error in the case of instrument of 8.3 volts, so the range is 0 to 150 volts. If you see the range, so the range is going from what? The range is going from 0 to 150 volts. The range is going from 0 volts to 150. 0 volts to 150. The percentage limiting error in the case of an instrument reading is reading of 8.3 volts. So he wants to measure a reading of 8.3 volts. This is a GATE question, GATE 1993 question. The percentage limiting error in the case of instrument reading of 8.3 volts with a range of 0 to 150 volts voltmeter having a guaranteed accuracy of 1%. 1% of guaranteed. So try to understand. So 1% of full scale value, that means how to understand that is 1 by 100 of 150. So that will be how much? 1.5 volts. 1.5 volts. Okay, so this is 1.5 volts. Is it clear? So we got 1.5 volts. Now percentage of limiting error for a measurement of 8.3 volts will be what? Expressing our error with reference to the measurement of 8.3 into 100. So how to measure this percentage? So this is 1.5 divided by 8.3 into 100. Please use 𝐂𝐤𝐴 because all the options are having long digits and perfect digits. So try to answer this question. It is coming as 18.072%. So the right answer for this question is 18. Option C will be the right answer. Anybody with any other answer, please try to confirm me. Yeah. Chalo. Similarly, let us see some more questions related to these errors. So see this famous question. This was a question asked by IIT Kanpur in 1995. See this question. Very interesting. Okay. Four ammeters, meter 1, meter 2, meter 3, meter 4 with the following specifications are available. So this is IIT Kanpur 1995. Meter 1 type is 3.5 dBm, that is the instrument name. the full scale value is 20, accuracy plus or minus 0.10%. Meter 2, PMMC, full scale value is 10 plus or minus 0.2%. Meter 3 is electrodynamic, full scale value is 5 plus or minus 0.5% of accuracy. Meter 4 is moving iron, full scale value is 1 plus or minus 1%. So a current of 1 ampere is to be measured. Okay, a current of 1 ampere is to be measured. To obtain the minimum error in the reading, one should use which particular meter? That is a question. So what can be the answer? Please tell me. Meter 1, meter 2, meter 3, meter 4. So how to do this type of questions? So 4 meters he has given. So how to solve this question? Let us see here in detail. So let us take this as a meter 1. Let us take this as a meter 2. I will go for the next page. This is a meter 3 and meter 4. So now if you see, meter 1 is 3.5 dVm. Meter 1 is 3.5 dVm. Let us take this as a meter 1. Let us take this as a meter 2. Let us take this as a meter 3. Let us take this as a meter 4. So forget about the name of the instrument. The instrument name doesn't matter here when it comes to the error calculation. It is related to my maximum value and limiting value. So name of the instrument not a matter. So here the full, because every case the measurement is current. The full scale value is 20 amperes. So let us take this a full scale value. So let us take this a 20 amperes. This is also some other current, and this is also some scale value. This is also some scale value. So very good questions. 20, 10, 5, 1. So this is 20 amperes. This is 10 amperes. This is 5 amperes. This is 1 ampere. Okay. So 20, 10, 5, 1. So here a current of 1 ampere is to be measured first of all. And what is a guarantee accuracy? 0.1, 0.25. So this is guarantee accuracy of how much? Plus or minus 0.1%. 0.1 percentage, and this is 0.2 percentage, 0.2 percentage, and this is plus or minus 0.5 percentage, plus or minus 0.5%, and this is plus or minus 1%. Okay, so now if I am going to see this 20 plus or minus 0.1%. So good evening matrix. So how to see the guarantee accuracy error? So percentage of guarantee accuracy error is plus or minus 0.1% of 20. So that is 0.1 by 100 into 20. So that is 1 by 10,000 into 20. So that is coming as how much? 0.02. Now for a measurement of 1 ampere is asking. So our measurement is 1 ampere. Remember this point. Our measurement is 1 ampere only. Our measurement is 1 ampere. So our measurement is 1 ampere. This also 1 ampere. So for a measurement of or percentage of limiting error for a measurement of, you can write like this. Percentage of limiting error for measurement of 1 ampere. Percentage of limiting error for a measurement of 1 ampere. So how to do this? So percentage of limiting error for a measurement of 1 ampere. So if you take that error 0.02 divided by is 1 ampere into 100. So it is going to become 2%. 2%. Now let us see this here. Same to same, what is given here? The percentage of guarantee accuracy is how much? Plus or minus 0.2% of your measurement value 10. So I can do here it as 0.2 divided by 100 into 10. So that will become 2 by 10, 20 by 1000. Same almost, right? 0.02. E also same. Now percentage of limiting error for a measurement of 1 ampere. For a measurement of 1 ampere. So how much it is going to become? Expressing this error with reference to 1 ampere into 100. So that is going to become as 2%. 2%. Got it? Now let us see another thing. This one. Percentage of guaranteed accuracy error is plus or minus 0.5% of 5. That is plus or minus 0.5 by 100. So that is plus or minus 5 by 1000, 25 by 1000, 0.025. 0.0. Percentage of limiting error. Percentage of limiting error for measurement of 5. Sorry. What is the measurement? Our measurement is always 1 ampere, na? Our measurement is only 1 ampere. All the cases, our measurement is 1 ampere only. So for a measurement of 1 ampere is expressing this error 0.025 divided by 1 to 100. So this is 25 by 1000 into 100. So 25 by 1000, 100. So it is going to become 25 by 10 point. Right? Any mistake we have done? Five amperes में 0.5%, 0.5 by 100, 5. The 0.25%. Next, if you see here, percentage of guaranteed accuracy error is equal to plus or minus 1% of 1. That means 1. So now percentage of limiting error for measurement of 1 ampere will be how much? That will be expressing this error difference to our measurement. It is going to become as 1%. Sorry, this is wrong calculation, na? 2.5%, na? This is 2.5%. So now if you see the options, meter number 4 offers 1%, meter number 3 offers 2.5%, meter number 2 offers 2%, like this. So what is the least error possible here? The least error is possible in the meter number 4. So in the meter number 4, the least error is possible. Mastrix, thank you. I have done a mistake. Very good catch. Meter number 4. Okay, so let us go for next question. So like this, there are many possible cases the questions came the previous cases. Okay, so now let us go for some more futures here. See here, how to solve this question. Try to solve this question. IIT Kanpur 2001. IIT Kanpur 2001. How to solve this question? Resistance R1 and R2 have respectively nominal value 10 ohms and 50 ohms. So the resistor values are 10 ohms and 50 ohms. So this is 10 ohms. So let us take this the R1 and this the R2. R1 and R2. Okay. Resistance R1 and R2 have respectively nominal value of 10 ohms and 5 ohms and tolerance of plus or minus 5% and 10%. So this is a tolerance of plus or minus 5%. This is a tolerance of plus or minus 10%. The range of the values for the parallel combination of R1 and R2 is dash. So R equivalent will be what actually? That is R1 R2 divided by R1 plus R2. We know, everybody know this one. So now if you see this particular value of R1, what is the R1 value? First let me write here all the information first. So if you take the R1 is equal to 10 ohms plus or minus 5%. That means its value is tolerance value 10 plus or minus 5 by 100 of 10. Am I right? 10 plus or minus 5 by 100 of 10. So how much it is going to become? 10 plus or minus gets cancelled. This becomes 0.5 and then 9.5 to 10.5. Okay na? I mean to say either it can become 9.5 or 10.5. Am I right or not? So this is a possibility for R1. Similarly, what is the possibility for R2? R2 is 50 ohms plus or minus 10%. This is 10 ohms and 5 ohms. Huh? I think it's 5 ohms, right? Don't make the mistake. It's 5 ohms. It's 5 ohms. Are you understanding? These are 5 ohms. Very good, very good. So 5 ohms. So let us take these 5 ohms plus or minus 10%. That means what I can write? 5 ohms plus or minus 10 by 100 of 5. Okay na? 10% of 5. That means that will be 0.5. So that will be 5 plus or minus 0.5. So that will be either 4.5 or 5.5. So these are the values of R2. Okay, va? So 4.5 and 5.5. So this is 9.5, 10.5. This is 4.5, 5.5. Is it clear? So now I can take any either combination. So what is a R equivalent? Suppose if I am taking staged case 1, I am taking a set of R1 minimum, that is 9.5, R2 4.5. This is 9.5 and this is 4.5. So what will be the R equivalent? R equivalent is equal to R1 R2 divided by R1 plus R2. So how much it is going to become? 9.5 into 4.5 divided by 9.5 plus 4.5. Please calculate and check. Similarly, other possibility case 2. Case 2. What is the possibility of R1? It can be 10.5 and R2 will be 5.5. So R equivalent is equal to R1 R2 divided by R1 plus R2. So it is 10.5 into 10.5 into 5.5 divided by 10.5 plus 5.5. Please calculate and how much answers tell me. 9.5 into 4.5 divided by 9.5 plus 4.5. So it is coming as 3.0535 ohms in this scenario. Here 10.5 into 5.5 divided by 10.5 plus 5.5. So it will be how much? 3.609, 0.661 ohms. So the resultant will be in the range of 3.0353 ohms or 3. These are the possible combinations. So if you see the possible combinations, 3.06, 3.61. So closest answers, if you see 3.0 after what is the closest answer is 3.0535, 3.61. 3.6 is here. Option A will be the matching answer. Yes, perfectly matched tricks. What's your name? Very good catch. How many of you are watching in the live session? Please try to give some good comments, whether are you following or not. I want to see your feedback. Anybody in doubt? Can let me know here. I'll be happy for your doubts clarification. If anybody is having any doubts, you can post here. Anybody, any doubts? Very good. Thank you, Bharat. Very good, very good. Where are you from? Nice. Will you go for the next question? Kabam, very good. Now let us go for one more question. Kabam, Telugu abbayi meeru? Okay. Thank you. Chalo, we have discussed up to now accuracy. Let us go for next characteristics. Precision. What is precision? Precision ante emiti? Can you tell me what is precision? Precision, how we can define? How we can define the precision? Precision can be defined as how? Can you tell me what is precision? So precision is defined as what? Precision. Precision means it is a measure of repeatability. It is the measure of repeatability. How far you are able to repeat the same value. Suppose I am measuring a particular voltage across a resistor. The voltage across a resistor is to be actually 5 volts. As per the calculation of voltage division rule, it should be 5 volts. But what I am doing, I am using a voltmeter and I am measuring. I am the first person. I am measuring. I got 4.8 volts. The next student has measured. He got 4.75 volts. The next student is getting 4.81 volts. You understand my point? So what I mean to say here, first of all, we neither of all 5 members are not getting the true value 5 volts. Precision is nowhere related to true value. accuracy is related to true value, precision is nowhere in true value, but we are getting some value, but all of our values are very closed, but they are not related to true value. I am getting 4.5, he is getting 4.6, he is getting 4.51, like that. This is what we call as measure of repeatability. Very good, measure of repeatability, okay, or measure of reproducibility also we can say, measure of repeatability. It is the ability of the instrument to repeat the same value. Suppose this is the voltmeter. Let's try to understand. This is the voltmeter. This is 0 volts to 5 volts. Okay, na? So this is a 0 volts to 5 volts. True value is 5 volts. True value is 5 volts. But student number 1, when you are doing the calculation like this, so this is our thing. So this is our student number 1, student number 2, student number 3, like this, student number 4, 5. So the first student got some other value, second student 4 and 5. So the first student got the value as 4.7 volts, second students 4.8 volts, third students 4.5 volts, fourth students 4.6 volts, fifth students some like 4.7 to 4.7 volts. So it is repeatably coming around 4.5 to 4.7. Is it true? No, it's first of all it is not accurate, but it is ability to repeat the same value. Okay, so this is what we call as repeatability or precise. Okay, of course too much of precision is automatically closest to the accuracy. For example, another set of table will see. So here set of students and their values, if we see, so this is student number 1, 2, 3 and 4. So if you see this, 5 students, one more table, we can take one more row. So if you see this, now if you observe 5 students are doing the experiment analysis, 5 students are doing the experiments analysis. First student got 3 volts, second student got some 2 volts, next student got some 4 volts, so next student got some 1 volt, next student got some 2.5 volts. Now if you see this, and next one, if you see this, see the different scenarios. Suppose here if you see, one, 2, 3, 4, 5. Suppose if you see this set, .2 volts, see this 2.4 volts, 2.5 volts, 2.35, 2.54, 2.5. Now what do you understand? Here this is, if you check this, they are repeatable, but is it accurate? So this is, precision is good, but accuracy is poor. But if you see this one, here precision is poor, accuracy is also poor. But if you see this here, accuracy is good, automatically precision is also good. So a highly precise instrument may not guarantee the accuracy. Highly precise does not mean it should be true. The 5 students have done the experiments, 5 fellows have not given the true value, but they are given the repeatably same. So this is the scenario you have to understand. I hope all of you understood what I mean to say. So what is the statement I can say? A highly precise instrument, a highly accurate instrument is precise, but a highly precise instrument may not be necessarily accurate. Am I right or not? If you see here, it is highly precise, but it is accurate? No. It is highly accuracy, automatically highly precise. So this was a question asked once in the GATE paper as a theory question. Very rarely we can have theory questions. Number of theory questions are coming nowadays. See here. What can be the answer for this question? Try to answer matrix. A precise measurement guarantees accuracy of the measured quantity. No, false. Because a precise does not related to accuracy. Accuracy is related to precise, but precise does not related to accuracy. Am I right? A precise measurement guarantees accuracy of the measured quantity. False. Are you agreeing matrix? Very interestingly, one more question will go now. If you see this question, what is the answer for this question? A current of 2 plus root 2 sine of 314t plus 30 degrees plus 2 root 2 cos 942 plus 45 degrees. Yes, thank you. So how to answer this question? So first let me write a current of I of t. If you check 2 plus root 2 sine 3142 plus 30 degrees root 2 cos of 942t plus 45 degrees. Okay, va? So this is a current. It is having some DC component and AC component also. What is there here? It is given as a thermocouple type 5 amperes full scale class 1 meter. So first of all, it is a instrument like this. Zero to 5 amperes. So this is 5 amperes full scale, plus or minus. Class 1 thermocouple. Class 1 meter he has mentioned. Class 1 meter means 1% guarantee accuracy here. 1% of guaranteed. This is 1%. Okay, so 5 amperes plus or minus 1 by 100 of 5. So this will become 5 amperes plus or minus 0.0. So on a full scale, it is 0.05 error. On a full scale, 0.05. So question here is, it is used for a measurement of this current. First of all, it is thermocouple. So if you see this, thermocouple measures the RMS. So what is the IRMS for this equation? So the RMS like this. So if you check the IRMS, so this is 2 square plus this is root 2 by root 2 whole square plus this is 2 root 2 by root 2. So how much I am going to get? If you check, this is 1, this is 4, 1 plus 4, 5 plus 4, 5 plus 4, 9, root 9. So root 9 means I am getting 3 amperes. So what do you understand? I am using the instrument for 3 amperes. If you correct this, it is going to become as 3 amperes. So 3 amperes for how much? So for a measurement of 5 amperes, the error is 1%. So percentage of limiting error for a measurement of 3 ampere is what is the question asked? So is asking, see here, the meter reading is asking, it's a class 1 thermometer. Class 1 thermocouple means 1% over the guarantee accuracy error. And 0.05 is the error when you get a reading of 5 amperes, but we are not measuring 5 amperes, we are measuring 3 amperes. So we are measuring 3 amperes for a percentage limiting error for a measurement of 3 amperes is, what is that error? 0.05 for a limit of 3 into. So how much it is going to come? Please use a calci and tell me. .666%. That means the answer will be what? The measurement will be what? So if you check this one, so this is 0 to 5 amperes, बीच में 3 amperes आएगा. So this is 0 to 5 amperes. So बीच में कौन आएगा? बीच में our measurement is 3 amperes. Answer is plus or minus 1.67%. So this is the right answer. Check it. Is it matching or not with the options given? Yes, 3 amperes plus or minus. I hope all of you followed. These type of different model questions are possible. Anybody is having any doubts, you can post me. Anybody is having any doubts? So this is a way how error analysis will be coming into the picture, my dear. Okay, try to understand. So the next feature, let us go. The next feature is the sensitivity, I think. The next feature is a threshold resolution. So these are some basic questions, basic definitions, threshold and resolution. So what is a threshold and what is the resolution? Threshold means it is the minimum input to be given. It is a minimum input to be given for an instrument to get a response. Response means what? Non-zero output. Next comes the resolution. Resolution. Resolution means what? Anybody can type? What do you mean by resolution? Anybody can give the definition of resolution? 5 members are watching over there. So what is the resolution? It is a minimum increment to be given. It is the minimum increment to be given. It is a minimum increment to be given for an instrument from the threshold so that there will be a modification, in already available okay na? So that there will be a modification already available non-zero output, non-zero, and already there is output, okay na? So we are expecting that output to get modified. We are expecting that pointer to get modified, okay na? So that is possible for a smallest increment. So it is a minimum increment to be given for an instrument from the threshold so that there will be a modification in already available non-zero output. So this is a threshold and this is a resolution. So this is what you have to understand. Very, very good topics these all are. Okay. So what is the sensitivity? The next parameter is the sensitivity. This is also very interesting topic, sensitivity. So sensitivity always very, very important when it comes to the instruments. So what is sensitivity? If sensitivity, if you take any system, or any instrument, so this is the input, this is the output. So these are delta x, these are delta y. Input is changing from one point to another point, and let us take input x here and output y here. So this is the x and this is the y. So sensitivity of the system is equal to change in output to change in input. Change in output to change in input. So this is delta y by delta x is a sensitivity. For example, let us take a galvanometer. I will take an example here, a galvanometer. example I'm taking, example. So this is the galvanometer. So here I am getting the current and here I am getting the deflection. This is my deflection. So here the current is the input, degrees theta is the output. So sensitivity of PMMC is given as degrees per ampere, deflection per current, deflection, change in deflection divided by change in current. So what I can take this as degrees per amperes. This is what we call as deflection sensitivity of the galvanometer. You understand? So for example, if you take thermocouple, so for example, if you take thermocouple sensitivity, how to write? That is also very interesting. Thermocouple is an instrument which converts the temperature to voltage. So if you take the thermocouple, so this is a thermocouple. So this thermocouple, what it will do? Thermocouple changes input to temperature. Input is the temperature, output is the EMF. Understand? So this is the temperature and that is the EMF. So the sensitivity of thermocouple is delta E by delta T. Usually the units are microvolts per degree Celsius. So thermocouple equation, for example, sometimes you may give like this also. EMF of thermocouple is given as, okay, for example, if temperature is a T and the EMF is the E, mathematical oriented questions, math tricks you are there. EMF of the thermocouple, he may give some expressions like in the format 1.2 T plus 2.5 T square. Okay, so like this he can give. So 3 T cube, this is the expression. So what is the sensitivity of thermocouple now? Sensitivity of thermocouple is change in EMF to change in temperature, but the expression is given as E like this, so dE by dt. So how it will be now? So it can be taken as 1.2 plus T square means 2T, so that will be 5T, 3T cube, derivation of 3T, 3T T cube derivation 3T square, that will be 9T square. Suppose sensitive thermocouple at a particular temperature he asked, at a temperature of 100 degrees Celsius. Okay, then what happens now? This value 1.2 plus 5 into 100 plus 9 into 500 square. Let us take EMF is in microvolts. This is in degree Celsius. Now if you check how much you are going to get, that is the answer. So what I can write now, 500 into 500 to 9 plus 500 plus microvolts into 10 power minus 6, that is coming as 2.25 divided by degree. Okay, 2.25 volts per degree Celsius is the sensitivity. That's it. So these are the different ways of finding the sensitivity expression. I hope all of you understood. If anybody is having any doubts, please let me know here. So in this entire session, so what we have discussed, we have discussed some beautiful concepts of measurements. Okay, I've discussed some beautiful concepts of measurements. So these are the topics what we have covered. So we have covered the syllabus overview, and we have covered basics of error analysis, and we have covered some of the static characteristics of instrument, and we have covered accordingly some gate PV. Okay my dear, so these are the basic. So coming to our आपके लिए these are the options given. On Unity platform we are having interactive polls, 3D models library, live class notes and doubts, YouTube notification, dashboard and leaderboard, and video call facilities also available. Okay, so these are the new features on that our app, Unity app. And you can have doubts in the YouTube chat to send your doubts. Okay, so please go through this particular information. There are excellent features for you. Okay, thank you very much. We'd like to meet you regularly in this session. Tomorrow we'll discuss the second topic, measuring instruments. So if anybody is having any doubts, what is your feedback, you can post over there. I will be happy. Yes. Can you start ESC Electronics EMI course, sir? Let you know. I will let you know related to engineering service examination. Related to engineering service examination. I'm replying. Related to engineering service examination, if the YouTube channel starts, surely I will discuss. This is for gate related measurements. In engineering service examination related also, we are going to start YouTube sessions. There we will discuss the ESC prelims. Yes, I'm telling that if you want to go for IES, definitely we will let you know IES batch or IES. Already in the paid batch we are taking the IES classes. If it is in a YouTube, we have not yet planned. We are going to come with a YouTube plan also soon. Yes, Durga Prasad, I have replied you. Okay, chalo, take care, bye bye.